cool. We're going to continue on with 6.2 today, similar triangles. We're just going to do some tougher ones. So we've got 4 questions to look at, and they're, as I said, they're all pretty tough. So let's start with the first one here. We have to figure out how much is this side right here, this x right there. Doesn't look too bad, right? Alright, we have 2 similar triangles here. One's nestled inside the other one. So as I told you last time, for questions like this, you might want to draw them both separately. The first one, I guess the big one's ABC, and then the smaller one is DEC. And let's label what we know. In the small one, I'm going to start with the small one, we know that from D to C is 15. And we know from D to E is 7. And that's all we know. In the big triangle, we know from A to B is 11. Now, be careful. This is, what makes today's questions harder. How much is the distance from A to C? We need to know this distance from A to C. Well, it's not x, because x is only from here to here. And it's not 15, because 15 is from here to here. In fact, how much it is x plus 15. So that is what you have to put down for the distance of this side. Okay, now we do the same thing we did last day. It's kind of weird because you have this binomial here, right? So what 2 sides, corresponding sides, do you know both of them? This one, the 11 and the 7. So let's make that our first ratio. 11 to 7 equals, so now we look at the other corresponding sides. It's this one first. We did 11 first, so pick this side first. X plus 15 over 15. How are we going to solve that? Hey, it's time to do a little bit of algebra. You're going to multiply by the lowest common denominator. Or if you want, I'll give you a little cheat here. Remember cross multiplying? You can cross multiply here as well. What you do is you multiply these together, write down the answer, and multiply those together and write down the answer. So in other words, what you're going to do is multiply 11 times 15. So I'll just put 11 times 15 like that. And you're going to multiply 7 times x plus 15. It's probably easier if I got rid of these blue lines now. Okay, so I did 11 times 15, there it is, and 7 times x plus 15. So 11 times 15, 165 equals, be careful here, you know what you got to do here? This is your feeding the chickens or the mountains, or distributive property is really what we call it, right? So 7 times x is 7x, 7 times 15 is 105. Looks like a little bit of algebra here. Shouldn't be too bad. All we have to do is get this x by itself. Let's look for adding and subtracting first. I see a subtracting step right here. I'm going to minus 105 from both sides, which leaves me with 60 here, 7x there. Then last step, this is 7 times x, so I'm going to divide by 7, divide by 7. You get 60 divided by 7. Does it work? Can you do that? No, you can't. So do you remember what I told you to do? Just leave it, 60 over 7 equals, 7's cancel, you're left with x. We did it. We figured out how much this distance is right here. It's 60 over 7. If you don't like that, if it's hard for you to picture that, in mixed fractions, it's 8 and 4/7. So this distance from here to here is 15, and this distance, the x right there, is 8 and 4/7. But 60 over 7 is a great answer. Okay, let's do one more like that, and we're done. We've got 2 triangles again, so I'm going to draw my 2 triangles. Oh, sorry, it's horrible, but really doesn't matter. So the big one here is DAR, DAR, and Darla, and the small one here is KMR, KMR. All right, let's label what we know. In the small one, again, I'm going to start with the small one. I have from K to R is Y, and from R to M is 14. Now, in the big one, from A to R, that's here all the way down to here. How much is that? Well, it's 16 plus the 14, so you end up with 30. Okay? If you want, 16 plus 14 equals 30, but that side is 30. How about this side? How far is it? It's 11 to there, and it's y to there, so it's 11 plus y. Or if you want, y plus 11. Really doesn't make a difference. Okay, off we go. Which 2 corresponding sides do you know both amounts? These ones, the 30 and the 14. Okay, so I can put that 30 over 14 equals got to do this one first because we did the 30 first. So y plus 11 over y. Oh my gosh, we have two unknowns in this. It doesn't matter, it's the same unknown, they're both y. This is going to work again. Don't worry, we're just going to cross multiply. Multiply those together and make it equal to multiplying those together. Again, I'll get rid of this so you can see better. So we're going to multiply 30 times y. Well, what's 30 times y? 30y. I'll do it this way, I tell you what. I'll do it this way. We're multiplying 30 times y, and we're multiplying 14 times y plus 11. Okay, that's how we cross multiply that. The other way you can think of it, of course, you should have done this before as well. You're getting common denominators. You're multiplying both sides by 14y. The 14's cross out here, so you're left with 30y, right? 30 times y is 30y. This is the real mathematical way to do it. I shouldn't teach you these tricks, cross multiplying. And over here, the y and the y cross out, so you're left with 14 times y plus 11, just like I have here. So there's our distributive property, feed the chickens. What do you get when you do that? You go 14 times y is 14y, and 14 times 11 is 154. Now, what's your next step? You have y's on both sides. We don't want that. We want to get all the y's to one side. So I would recommend you get rid of this 14y. Subtract 14y from both sides. If you do that, you'll be left with 16y equals 154. And last thing to do, 16 times y, you have to divide by 16 and divide by 16. Uh-oh. I don't know what that is. 154 over 16. Let's see. I could divide them both by 2 and I'd get 77 over 8. And I think that's it. I think that's your answer right there. Again, if it's hard for you to picture what that means, in a mixed fraction that's 9 and 5/8. So let's see how that looks. You can't always trust the drawings. Sometimes they draw them horribly. But basically what that's saying is, if this is 11 from here to here, then we just found it's 9 and 5/8 from there to there. Sounds about right. Looks good. So I trust we've done that right. Okay, 77 over 8 is a good answer. Okay, on to the back. So we have two triangles here. Maybe what I'll do to start is do a sketch of both of them. So we have our big triangle, something like that size, and then we have a smaller one about like that. Alright, let's fill in what we know here. So in the big one, we know the whole bottom, along the bottom here of the big one, the whole thing is 15. So we can put 15 here. On the side, we know that it is 10 plus 6, right? This whole side here is 16. Okay, now let's look at the small one, right? We're looking at right here. So this side's no problem. This side's from here to here. Sorry about my terrible drawing. That's 10, so I can put 10 there. Now we have a little bit problematic. We want to know how much this side is there. Well, that side equates to this side right here. How much is that? It's not 15, is it? It's less than 15. How much less than 15 is it? It's this much less. It's x less. I know that sounds weird. Let's say that this x there, let's say it was 5. Well, if this was 5, how much would the blue part be? It would be 15 minus 5. I'm just going to write that over there. 15 minus 5. That's how much it would be. Okay, but this might not be 5. Let's say this was 10. If this was 10, how much would this be? It would be 5, because it would be 15 minus 10, and you would get 5. Alright, let's do one more. If this was 7 right here, then how much would this bit here be? It'd be 8, wouldn't it? It'd be 15 minus 7. Okay, well, we don't know how much this is here right here. We only know it's x. So how could we write an expression for this amount right here? It would be 15 minus that amount. Remember, we always subtracted that amount, whether it was 5 or 10 or 7 or x. So this amount right here would be 15 minus x. That's probably the hardest part of this question. 15 minus x right there. Okay, and we're trying to find out how much is x. So we can set up our ratio here. If we look at the big one, this side here, 16, corresponds to 10. So there's our first fraction, 16 over 10. We had the big one on top here, so put the big one on top here, 15. And that corresponds to 15 minus x. And now we're going to cross multiply again. And remember, the way we're going to do this is we're going to multiply this times this. That's pretty easy. 10 times 15 is 150. and we're going to make that equal to the other diagonal, 16 times all of this. So that would be 16 times 15 minus x. And again, on the right hand side here, you've got some distributive property. So we have 150 equals 16 times 15 is 240, and then 16 times negative x, or negative 1x if you want, 16 times negative 1x is negative 16x. Okay, we've got to get this x by itself, so we've got to look for adding or subtracting first. Let's subtract 240. Subtract 240. 150 minus 240 equals negative 90. So negative 90 equals negative 16x. This is negative 16 times x. We do the opposite and divide by negative 16. Thankfully, we'll get a positive answer. A negative answer wouldn't make sense. A negative divided by negative is positive. And 90 divided by 16, it doesn't go in evenly. So we could put 90 over 16, but that's not in lowest terms. Divide them both by 2, you get 45 over 8, which is in lowest terms, so that's fine. Or you could put it as a mixed fraction. 8 goes into 45 5 times, that gets you up to 40, with 5 eighths left. Or if you want, you could take a calculator and figure out what 45 divided by 8 or 90 divided by 16, either one you want to do. Just figure out what that is, and it is 5.625. Never is satisfying when you get these decimals or fractions like this, but it is correct. Oh, and I forgot to put x equals. I'll put it up front. X equals, sorry. These are all possible answers for you. This first one's not totally correct. It's not in lowest terms. Alright, this last one always gives me troubles. I kind of hate this one. The first question I have for you is, how many similar triangles are there in this thing? I'm going to call this A, B, C, and I'm going to call this part right here, I don't know, I'm going to call it M. I don't know why I don't call it D. I'm just going to call it M. Why not? So let's first of all find our 3 similar triangles. So bear with me a little bit here. The first one I'm going to look at is the most obvious one, the biggest one. So the one I've outlined in red here. So I'm going to remove that from here. Hey, pretty fancy, right? I'm doing my best. And label this. It is A, B, C, and there's a right angle, 90-degree angle, right here. Okay, the next one that you can probably spot here is this medium triangle right here. So that's this one here, the red one here. And if I remove that one, here we go, our right angle is up here, but I'm not going to draw it because what I'm actually going to do is I'm going to spin this one to here, and then it's now a mirror image of this. Can I flip this over? Well, I can flip it to there and then spin it, and hopefully you can see that, whoops, I didn't quite join it together there, but hopefully you get the idea. You can see these are similar triangles too. Here's the right angle, which was right here. So that was vertice M right here, and this is my A here, and this is C here. Now, not sure that they actually are similar. You just need to find 2 angles that are congruent, equal to each other, and then you know all 3 are, because all 3 angles add to 180. If you find 2 that are the same, the third one has to be the same as well. And if you look, those first 2 triangles we looked at, they both share angle C, right? In the big triangle, angle C is right here, and in the smaller triangle we looked at, angle C is right here. So they have to be similar to each other. They're different sizes, but they both have the same angle, right angle here, and this angle C here. So then this angle, B and A, have to be the same in order for the angles to add up to 180 in both triangles. Okay, the last triangle we'll look at is the small one up here. So there it is. I can remove it again, and I might have to do some flipping again. Oh, I really don't like this. Here's my right angle. So I have it like this, and now I'd like to flip it over, wouldn't I? Let's try flipping it. Okay, I flipped it, and there we go. If I put it like that, you can see again, it looks exactly the same. Here is my right angle down here. So where was that right angle in the small one? I don't see that right angle there. That right angle would be right here. Why is that? Because if this is a 90-degree angle, this also has to be a 90-degree angle. It's a straight line, and the angles add up to 180, so 90 plus 90 equals 180. So this is your right angle right there. which is again at M. I should have the M a little more over like that. So that's at M. The smaller angle here is the A, and the bigger angle is your B up there. Okay, so there's actually 3 similar triangles, so there's all sorts of questions they could ask you about this. Now what we're trying to find is what this side Y is here. So let's label this. I'm still confused about this, to be honest, but we'll figure this out. Between M and C, well, M and C is right here, M and C. It's 20 between M and C, so that's 20 right there. And between M and B, it's 5. Well, here's an M and B, so it's 5. And between B and A, well, B and A is either here, Y, because between B and A, or here, oh, this looks more promising, Y. That's it. That's all they give us. But there is one more thing we have here. We have from B to C. From B to C is 5 plus 20. So that's 25. From B to C, it's 25. Now, this doesn't look too promising, does it? I mean, this 20 here, it doesn't correspond to either side that you know, so that doesn't seem too useful. And then we have the Y that corresponds to the 5, and the 25 that also corresponds to the Y. What? How do we do this? It actually turns out you can do this by looking at these 2 triangles, this one and this triangle. It will actually work. It's a little bit different, but we can do this. So let's take a look. Let's take a look at the big one, and this Y corresponds to what side? The 5. So Y over 5 equals, we did the big one first, right, the Y, so we'll do the big one first here, 25 over, what's that correspond to in the other one? Y as well. Huh, that looks kind of strange, doesn't it? But let's try it. Let's try cross multiplying. So what we're going to do is we're going to multiply this times this, Y times Y. What's Y times Y? Remember back to polynomials? When you multiply, you add the exponents. So there's a 1 here, there's a 1 here. Y times Y is Y squared. And that's going to be equal to whatever this equals, 5 times 25. Well, 5 times 25 is 125. So we just have to solve this. Y squared equals 125. What? How do you solve that? Well, we have to undo this squaring, don't we? We have to do the opposite of squaring. You know what the opposite of squaring is? Unsquaring. Unsquaring is square root. So we're going to square root this, and we're going to square root this. Square root of Y squared. You should know that. Because squaring and square root are opposites, they cancel each other out. You just get Y. And the square root of 125. Well, there are ways to simplify that, but you haven't learned it yet. So why don't we just take a calculator and throw 125 into the calculator and hit square root. And if you do that, you get 11.18. Goes on forever. It's an irrational number, but approximately 11.18. And that's your answer. Boy, is that last one ever hard. It really boggles my mind when I try to figure out which side corresponds to which side here. But I have a terrible spatial awareness. You might be a lot better at that than I am. Alright everyone, good luck. Some of the questions today are pretty hard, so let me know if you need some help. Bye-bye.